Hello everyone. Today in this video we are going to discuss about data architecture design. So these are all the contents we are going to cover in this video, that is introduction of data architecture design and how the data architecture design works and what are the benefits of data architecture design. Let us see what it means. See, when it comes to managing the huge amount of data, it needs big data tools and technologies to make use of various software and procedures which lie in big data ecosystem. And it is a system used for ingestion, storing, and processing the large amount of data that can be analyzed for business gains. And it is a blueprint of big data solution based on the requirements and infrastructure of business organizations. So it this architecture saves the companies money, and also it helps them to predict the future trends and improve the decision making. Now, when it is used when we have large quantity of data for storing and processing. Then we use this architecture, and also to transfer the unstructured data for analyzing and reporting. We use this architecture, and it can be used by business industries or manufacturing companies, retail companies, healthcares, etc., so that it helps them to get better decision making and better understanding and analyzing of big data and predicting the future needs and trends. Now let us understand how this data architecture design works. This is data architecture design diagram looks like. So here we have 5 layers: layer 1, layer 2, layer 3, layer 4, layer 5, and each layer have the corresponding functions. So now let us see one by one how it works. Layer 1: identification of internal and external source of data. Once the data is collected, we have to identify the source of that data, whether it is coming from internal or external source of data or both. So here the internal source of data is nothing but the data is private that your organization owns, controls, or collects it. This is internal source of data. For example, let us consider your college is performing an analysis to figure out the highest marks in your class. This is the internal source of data. Now, external source of data. The data is collected from outside of your organizations. For example, social media, Amazon, Google, etc. Now, functions of layer 1. First one, sources for ingestion of data. So here, when data is collected, before ingestion of that data, we have to identify the source of that data, whether it is internal or external source of data. Accordingly, we have to perform the operation. Next, push or pull of data from the source of ingestion. So here, consider the amount of data needed at ingestion layer 2, and then either push from the layer 1 or pull by the layer 2 as per the mechanism for the usage. Next function, data types for database, files, web or services. Here, uh, here it finds the nature of the data that can be stored in database, files or web services. Next function, data formats: structured, semi-structured or unstructured for ingestion. So here the data which is collected, we have to identify the data format, that is it is a structured data or semi-structured data or unstructured data. Accordingly, we have to inject that data. So these are the functions of layer. Layer 2, data ingestion and acquisition. The data which we have collected in layer 1, we have to insert that data into your database or files for analyzing, and data acquisition gathers, filters, and cleans that data before put in any other storage solutions. Now functions of layer 2. First function, ingestion using extract, load and transfer, that is ELT. Here, the data ingestion is a backbone of any analytics architecture. The ELT will extract the data from the previous layer, and then it will loads that data and it is transferred to the data warehouse. So after that the analysis will be done. So this is the process of ELT. Now next function, data semantics. We can apply the data semantics in different methods such as replace, and we can append the new data element into the existing database, and we can aggregate the different sources of data and compact the data. So these are the data semantics. Next function, pre-processing. Before executing the data, we need to pre-process that data. That is, we have to check the missing values, unnecessary data, or other inconsistencies for further analysis, and we have to validate that and make corrections accordingly wherever it is necessary. This is pre-processing. And last function, ingestion of data from sources in batches or real time. When the data is ingested in real time, then it is ingested immediately as soon as the data arrives. So this is called real time ingestion. For example, let us consider bank ATMs. When we go for withdrawing the money from the ATMs, when we withdraw the money, we will get immediate message to our mobile. So this is real time process. Now, when data is ingested in batches, then the data items are ingested in some chunks at a periodic time of interval. So this is batches ingestion of data. For example, generation of bills, credit cards, etc. So this is all about layer 2. Layer 3, data storage. So we have collected the data in layer 1, and ingestion and acquisition is done on that data in layer 2. Now we have to store that data. Here the storage becomes a challenge when the size of data is large. So this layer focuses on where to store such large data efficiently for further access of that data. Now functions of layer 3. We have to consider the formats of the data, that is structure, unstructured or semi-structure of the data. Accordingly, we have to store, and we have to check the frequency of incoming data. This helps to determine the storage mechanism and compression of the data to save the space in the memory and data consumption. Now next function, that is Hadoop distributed file system. This SDFS stores the data in several locations, that is name node, which is the master node that splits the data and that is distributed in different data nodes. And each data blocks are replicated by default and distributed across the different data nodes. In case any of the data node fails, we can retrieve that data by having replica. So this is the advantage of SDFS. Now NoSQL. The NoSQL, it allows the high performance on large data set, and it can store the unlimited sets of data with any types. So some of the NoSQL data stores are MongoDB, Cassandra, Graph Database, and HBase. So this is about layer 3. Layer 4, data processing. This layer processes the data which we have collected in previous layers. Functions of layer 4, processing technologies. So for processing the huge amount of data, we have some technologies such as MapReduce, Hive, Pig, Spark, and many more. Processing in real time, scheduled batches, or hybrid. The data can be processed in real time, scheduled batches, or hybrid depending upon the data which we have. And last function, synchronous or asynchronous processing. While processing the data, sometimes it will execute without interrupting from start to finish. But sometimes we may face the problem while processing the data due to some interruption in workflow. So this is layer 4. Now layer 5, data consumption. This layer consumes the output provided by the previous layers and present them to the relevant output. Now functions of layer 5, export of data sets to cloud, web, etc. Here we will export the data set to the web application or cloud that lets you to run the queries of large data set faster. Datasets usage, that is BPS, IPA, BIS, knowledge discovery. So, the data usage of reporting and visualization that covers the business goals that needs to access the data and analyze that data and integration into the business decision making, and knowledge discovery to find the patterns that leads to actionable knowledge from large data set. And final function, analytics. The analytics may done on real time, near real time, or scheduled batches, and after that, the visualization and reporting is done on that. So these are the 5 layers of data design architecture. Now, benefits of data design architecture, it reduces the cost. So the big data technologies such as Hadoop can significantly reduce the cost when it comes to storage of large amount of data, making faster and better decision. So using streaming component of big data architecture, you can make decision in real time, predicting future needs and creating new products. So it helps you to estimate customer needs and predict the future trends by analyzing the big data from multiple sources. So these are all the benefits. So now at the end of this video, we all learned how the data design architecture works, and where it is used and when it is used, and what are the benefits of this data design architecture. So thanks for watching.